Hello again. Thank you for joining us. I'm now going to go over questions 17, 18, and 19 again in this packet. It looks something like this. So if you looked at the last video, I went over 14, 15, 16. Now I'm going to go over 17, 18, 19. So I'm going to start here with question 17. It right off the bat says standardized test, normally distributed, bam. I need one of these graphs. It says mean is 20, standard deviation is 6. So right off the bat, I know I can use my fancy calculator to calculate this, even though in Algebra 1 I couldn't. So I'm going to go ahead and write the mean plus the standard deviation and the mean minus the standard deviation. And that means that we know that if it's normal data, it's shaped like this, there's the mean and there's the standard deviation. So I'm automatically thinking to myself, I think I can calculate a lot of information from here because a lot of the inputs in here require me to know the mean and the standard deviation. So the mean again is x bar is 20 and s sub x 6. So as I move forward in the question, I notice it says calculate the IQR. So understanding what that word means is really crucial to the question. My IQR is quarter 3 minus quarter 1. So quarter 3, if it was a basketball game, means that 75% of the information has been collected, and quarter 1 would be 25% of the information is lower than that. Or think about it as the first quarter of the ball game's over. So I actually know the area under the curve. If I drew a picture of that, I could say to myself, okay, I'm not sure where it falls exactly on my curve, but I do know that quarter 3 would be 75%. Or the area under the curve to the left of the data would be 0.75. If I know the area under the curve and I know the mean and I know the median, I can use inverse normal function. So that's the function in my calculator I want. So using the inverse normal function, I go to my calculator, type menu, stats, and this is a distribution, so click distribution, and I see my third selection is inverse normal. So it looks something like this, inverse normal. So notice I have all 3 pieces of information that my calculator lists. I know the area is 0.75 for quarter 3. I know mu, which is my x bar. Mu is the population mean, so I type 20, and then I type 6, and then I hit enter. So typing that in, mean is 20, standard deviation 6, everything's falling into place here. And that's going to give me my x value, and it says 24.04. So I actually know the x value at quarter 3. It's 24.0, I'm going to round 0.05. So that lands right about there on my graph, which makes sense. Now I'm going to do the same thing. Instead, though, I'm going to swap out my area instead of 0.75 to calculate quarter 1. That's when only 25% of my data. So I'm going to do exactly the same thing. I'm going to go to menu, stats, distribution, inverse normal. Now my area is 0.25. Mu is still 20. Standard deviation still 6. Area under my curve is 15.95. Or excuse me, not the area under the curve. The area under the curve is 0.25. But my x value is 15.95 at quarter 1. 15.95. Now to calculate the interquartile range, I just want to subtract those 2 values. So when I subtract 24 from 16, I get 8. That's selection C. Let's take a look now at question 18. It looks like a confidence interval question. It doesn't look like I have to calculate the confidence interval. It's looking like I just have to know whether or not I know the script. So when I read the question, I say to myself, regardless of what the context is the script right? So a confidence interval, in essence, we say that we are 90% confidence that the interval from blank to blank captures the true mean. So I read through these, and the only one that really talks about the true mean is question C and option E. So right off the bat, I'm kind of glancing at just C and E, and now I'm trying those out and see which one sounds the best. So in essence, when I do a confidence interval, in fact, a 90% one, if I repeat the process many times, only 90% of the time am I going to capture the true mean, which means that 10% of the time I'm not. That's why I'm able to say when I do a confidence interval, I'm 90% confident that the interval from blah to blah captures the true mean. That's really sounding like question C. So I'm going to go ahead and select C because it matches my script. And again, if you missed this question, you should go ahead and write out, we are 90% confident that the interval from blank to blank captures the true mean. Captures the true mean of babies born in centimeters, yada, yada, yada. So I would practice writing this script, which will help you find the right answer. This will also help you on your free response. Now let's look at question 19. This, in essence, is also a confidence interval. And I notice this because when I see it, each of my choices is actually a confidence interval, isn't it? So I'm just going to jot that above 18. I'm going to write CI, because again, 18 and 19 are both confidence interval questions. Now as I look at this confidence interval question, I say to myself, wait a minute. This time, they want me to be 98% confident that the interval captures the true proportion. So this is a proportion question. Now they're asking me to decide what would happen if instead of doing a 98% confidence interval, I switch it up and do a 95% confidence interval. So I'm going to have to move the paper and use my hands to explain this. If I'm capturing like a net, capturing the true proportion, if I have to be 98% confident, I need to make the net wider. So it sounds that originally I did a 98% confidence interval, and I got the interval from 0.32 to 0.46. Now they want me to only be 95% confident. So that means, okay, I can be a little more accurate. I can move my net closer to the middle. When I look at my choices here, again, I'm looking at the number 0.32 and 46, so 32% to 46%. If I'm getting a little closer to the middle, the only one that gets closer to the middle is the last one. So notice, the only one that does what my hands did in my example is E. All the other ones appear to be shifting. So again, if I'm 98% confident, now I'm 95. If I have to do a 90% confidence interval, what's happening here is my critical value is getting smaller. So out here I'm multiplying by 1.96. Here I'm multiplying by like 1.6 from a 90% confidence interval. But what's not changing is where that statistic is, where the center of my data is. So E here is my best answer. B, C, and D look ridiculous because when I change a confidence interval, I'm moving both hands, and they didn't move the first hand, 0.32. So ultimately, the only two I'm looking at are A and E. Once again, though, if I look at A, it looks like they went from 0.32 to 0.3. So it looks like they got bigger there, and that's a problem. And so A looks as if I went from a 98% confidence interval to maybe a 99 interval or a 99.5. So that's what I'm going to write on there. That looks more like I made the confidence interval bigger, making my net bigger. That should help make sense of question 19. Thanks for watching.